Right, today we're diving deep into Java error handling.
Sounds intriguing.
We've been looking at this library that claims it can make your code not only cleaner, but way faster.
Yeah, this library is fascinating. It helps solve a problem that Java devs face all the time,
Oh,
how to handle successes and failures in your code, but without the usual performance cost of exceptions.
right, because exceptions can get pretty clunky, so
Yeah.
we're aiming for, grace under pressure.
That's it. And the solution this library offers is this really elegant result object.
Okay.
It's a way to package up the outcome of your code.
Right.
Whether it's a success, or a failure, bundles it all up neatly.
So it's like a outcome package deal.
Precisely.
Okay, before we get too far, let's back up for a second. For those who might not be as familiar, could you remind us how Java's optional helps avoid null checks?
Absolutely. An optional is basically a container.
Okay.
It might hold a value.
Gotcha.
Or it might be empty. So instead of directly accessing a value that could potentially be null, you wrap it in an optional.
Yeah.
Then you can check if a value is actually present.
Yeah.
And if it is, you can retrieve it safely.
Okay.
And that right there helps you avoid those pesky null pointer exceptions.
Right. The dreaded null pointer. So optionals are like that safety net.
They are.
So how does result then build on that?
Think of result as optional, but, way more powerful.
Okay.
Optional, it helps you avoid null checks, but it takes it a step further.
Okay.
Instead of just saying, is there a value here? You're asking, did this operation actually succeed?
Yeah.
And if it didn't, why not?
So instead of an exception just crashing everything,
Exactly.
result gives you this structured way to deal with the failure.
It gives you that valuable context about what went wrong.
Right, which is key.
Essential for building robust applications.
Yeah. Now, some folks might be wondering, why not just stick with the old way?
The good old traditional exception handling.
Yeah, why even bother with this whole result thing?
It's a valid point. The answer really boils down to performance and just cleaner code.
Okay.
Exceptions are great, don't get me wrong, but when you use them for things that aren't really exceptional cases,
Right.
they can become resource intensive. Every time an exception gets thrown, the JVM has to do a lot of work behind the scenes,
Yeah.
and that can really bog things down, especially if these failures are part of your normal operations.
So you're saying if you're always throwing and catching for stuff that isn't really that exceptional?
Yes. You're actually hurting your app's performance.
Gotcha.
And beyond performance, let's talk about readability. Nobody likes a code base full of try-catch blocks, right?
Right.
It makes it hard to read, hard to understand. Result objects, on the other hand, provide a much cleaner way to handle these expected failures directly.
So it's like you're saying result is more straightforward.
Makes your code faster
Well,
and easier to maintain.
okay, you've convinced me. So we've got these result objects.
Yes.
How do we actually create them in our code?
Luckily, it's pretty straightforward. They have these factory methods.
Okay.
If your operation is successful, you use results.success, and you wrap your successful value with that.
Simple enough.
Then you have results.failure for failures.
Right.
You pass in an object that represents the reason for the failure.
So it's like saying, hey, this worked and here's what you get, or nope, this failed and here's why.
Exactly. It's all about clear communication.
Right.
Now, there is this other method, results.ofnullable. This one is super helpful for handling those nulls we often encounter in Java.
Because Java.
Exactly. You can create a result from a value that could potentially be null.
So you're covered either way.
Yes. If the value is actually there, great. You get a success. If it's null, you get a failure.
Okay.
All nicely packaged and ready to handle.
That's pretty neat. But what about when we're working with, legacy code?
Ah, the joys of legacy code.
Code that still throws exceptions.
Don't worry, they've thought of that too.
It's got a solution for everything.
Exactly. You have results.ofcallable, which bridges the gap between those exception-throwing parts of your code and this new result-oriented way of doing things.
It's like building a bridge between the old world and the new.
Exactly. You're essentially wrapping those exception-throwing operations inside a result.
Okay.
So you have a consistent way to manage successful outcomes and potential failures throughout your code.
It's like you're bringing order to the chaos.
Exactly. And the best part is, once you have these result objects, the possibilities are pretty much endless.
Endless possibilities. I like the sound of that.
You can use them in all sorts of powerful ways to make your code more robust and expressive.
So we've got these result objects. We know how to create them. We know they're more efficient, and we know they help wrangle those null values.
We're just getting started.
Okay, now, how do we use them in our code?
That's the fun part.
Where do these result objects really shine?
Well, think about what you usually do with optionals, like checking if the value is actually there, extracting it, maybe providing a default value.
Right.
Result can do all that, but with the added bonus of handling failures gracefully.
Okay, that sounds promising.
For example, instead of using isPresent, like you do with optional, you've got has success and has failure.
So we can directly check the outcome of something.
You got it. No more messy nested if statements.
I can get behind that.
You just ask the result directly. Hey, were you successful? Or did you run into a problem?
Much more direct. I like it. So how do we get to those values? Whether it's the success value or the reason for the failure.
Here's where it gets really cool.
Okay.
You use getSuccess to grab that success value.
So it's like similar to get with optionals.
Yeah, exactly. But with getSuccess, you're not going to run into an exception if the result's a failure.
Right. That's a relief. What about accessing the failure reason? How do we get that?
You would use getFailure for that.
Okay.
But here's the best part. You have or else.
Or
Yeah. Remember those nested if-else blocks we always write? To handle default values if something's missing.
oh yeah, I've written my fair share of those.
Well, or else streamlines all that. If your result is successful, boom, you get the value. Failure. Or else jumps in with a fallback value.
So much cleaner than all those if statements.
Right.
It's like result is encouraging us to think about both success and failure gracefully.
Exactly. Handling both with equal grace.
I like it.
Yeah.
But what if we want more control over that fallback?
They've got us covered there too.
Yes, of course they do. We have or else map.
Okay, or else map. What's that about?
Let's say you want to apply some logic to the failure reason
Okay.
to generate a default value that makes sense in that specific context. Or else map is your friend.
Oh, interesting. So can you give me an example? When would you use or else map?
Let's say you're trying to, read a configuration from a file, right?
Right.
And that file's missing.
Happens all the time.
You don't just want to return some hard-coded default.
You might want to log a warning or try loading a default configuration from somewhere else.
Okay.
That's where or else map comes in. You can put all that logic in there nice and clean.
So we're not just handling errors. We're gracefully recovering, maybe taking alternative paths based on what caused the failure.
Precisely. And we're just scratching the surface here. Remember I said result was optional on steroids?
Oh yeah, I remember that.
Well, buckle up. Hit me.
We're going beyond just treating result as a container and stepping into some cool functional programming stuff.
Okay, I'm intrigued.
Get ready for filter, map, and the big one, flat map.
Hold on. We're talking about filter map. That's streams territory, right?
You're right.
We use those with streams, like when we're processing sequences of data, not just single values. So how does that work with a result?
Great question. It's all about thinking of result as a special kind of stream, one that might hold a single successful value or a failure. And just like with streams, these functional methods let us manipulate result objects in a really elegant way. Okay, you're blowing my mind a little, so walk me through it.
Let's start with filter. Let's say you have a result that contains a number, right?
Okay.
But you only care about it if that number falls within a specific range.
Right.
Instead of a bunch of if statements, you use filter.
So it's like applying a rule to it.
Exactly. If the value makes it through the filter, you get your successful result. But if it doesn't, it becomes a failure with a clear reason why it failed.
It's like result is our quality control expert.
I like that. Now, on the flip side, you have recover. Remember else for defaults.
Yeah.
Recover takes it up a notch. It lets you intercept specific failures and potentially turn them into successes.
Turn a failure into a success.
Yeah.
That's interesting. Can you give me an example of that?
Sure. Imagine you're trying to connect to a database.
Okay.
Now, if that connection fails, you don't necessarily want to just give up, right?
Right. You'd want to try again, maybe.
Exactly. You might want to retry a few times before throwing in the towel. Recover lets you build that retry logic right into the result flow.
So recover can swoop in and try again.
Exactly. If the first try fails, recover can retry, and if it connects, it just wraps the connection up in a successful result. Like nothing ever went wrong.
That's pretty slick.
It is, right.
So we have filter, making sure only the good stuff gets through, and recover is like our backup plan, smoothing things over if something goes wrong. What about map?
Map. Think of map as a way to transform the value inside a result.
Okay.
Let's say you have a result that holds a user's name.
Okay.
but you want to display it in all uppercase.
Right.
Instead of taking it out, checking if it's successful, and then uppercasing it, you can use map success.
Map success.
Yeah, it applies the transformation directly to the result itself.
Okay.
If the result is a success, the transformation happens. If it's a failure, the failure remains untouched.
So it's a way to change the value without messing with whether it was successful or not.
Precisely. And just like with filter, we've got a counterpart for failures, map failure. This one lets you transform the failure itself.
Interesting. So you could turn an error code into a message that people can actually understand.
Exactly. Or you could add some more context to the failure.
So we're building this really nuanced way of handling successes and failures.
We are.
But you mentioned flat map earlier, and I have a feeling that's where things get really wild.
You're right. Flat map is where things get really interesting. It's all about chaining operations that return results. The research gives this example with a pet store, right? Imagine you have a result pet that might hold a pet object if everything's good, or a failure reason if not. Now you need to get the owner of that pet.
Okay, makes sense.
But fetching the owner, that's another operation that could work or not, and it would give you a result owner.
Right, so we have 2 steps, and each one could potentially have a problem.
And without result objects, you'd probably be stuck with these nested if statements.
Oh, I've seen those a nightmare to follow.
To check the outcome at each step makes your code really hard to read and even harder to maintain. But that's where flat map success swoops in to save the day.
Flat map success. Okay, tell me more.
It lets you chain these result returning operations gracefully. So in our pet store situation, if you found the pet successfully, flat map success would take that pet object and use it to fetch the owner.
And if both steps work?
You get a result owner with exactly what you were hoping for.
Nice. But what if one of them fails? Either finding the pet or getting the owner.
Flat map success handles that too. It propagates the failure down the line. The beauty is, whatever happens at each step, you're always left with a single result.
So it's like a pipeline, where each step can succeed or fail, but the result carries the outcome to the next stage.
Exactly. A nice, clean pipeline.
Okay, I'm seeing how powerful this can be. You could build up some complex logic with multiple steps, and each step might have its own chance of success or failure, but you still keep this clean, result-oriented way of coding.
Exactly. And just like map success has map failure, you also have flat map failure for those times when you want to chain things based on a failure.
So going back to the pet store, if finding the pet fails, flat map failure could try finding a default pet or something.
Exactly. Or it could trigger some logging, update some metrics, whatever you need to do when that specific failure happens. It gives you a lot of control and it keeps your code clean and consistent.
This is really making me rethink how I deal with errors in Java. Instead of just reacting to exceptions, it's like we're in control, managing success and failure as a core part of our code.
That's the idea. And the library doesn't stop there. It offers even more tools to make things easier. One of them is lazy result. Have you ever had to calculate something, whether it's a success or a failure, and it was really computationally expensive?
Oh, all the time. Database queries, network calls, those can really slow things down.
That's exactly what lazy results are for. You don't calculate the result right away. You defer it until it's actually needed. You create a lazy result using lazyResult.ifSupplier, and you pass in a supplier that has the code for that potentially expensive operation.
So you're saying don't do the work until we absolutely need the answer.
Exactly. And the best part is you can still chain these lazy results, map them, filter them, just like regular results. All those transformations, they only happen if and when that lazy result is evaluated.
Wow, that's powerful. So you're not losing any expressiveness in the code, but you're making it smarter about when it actually does the heavy lifting.
You got it. And on the topic of elegant code, the research also points out how well this library plays with testing frameworks like AssertJ.
AssertJ? I love AssertJ. It makes tests so much easier to read.
Right. Those fluent assertions are fantastic. And the result AssertJ extension gives you dedicated assertions for your result objects. You can directly check if a result is successful, look at values, even inspect the failure reasons, all in a super readable way. Makes testing a breeze.
It sounds like they thought of everything. How we create these result objects, how we transform them, how we test them. But what about real-world applications, APIs, data exchange, all that JSON flying around. Does it work well with that world?
Absolutely. They have this dedicated Jackson module. It handles all the messy details of serializing and deserializing result objects to and from JSON. Imagine you're building a REST API and you're using result objects to represent the outcomes of your API calls.
Right. You wouldn't want to write all that custom code just to handle result objects in your responses.
Definitely not. And you don't have to. This Jackson module takes care of it all. You get that automatic serialization and deserialization for your result objects, just like any other data type. It just works.
So smooth. It seems like they've really gone the extra mile to think about how developers will actually use result objects in their projects and made it super easy to integrate.
That's the beauty of this library. It's not just about a new way to handle errors in Java. It's about giving developers a whole ecosystem to write cleaner, faster, and more reliable Java code.
So to wrap things up for our listeners, why should they care about these result objects? What's the big takeaway?
It's simple. Result objects can help you write better Java code. They encourage you to think about errors differently, to be proactive, not reactive.
And to treat successes and failures as equally important.
Precisely. Plus, your code becomes cleaner, easier to understand and maintain, and potentially way more efficient by avoiding those heavy exceptions.
Exactly. It's like you said earlier, a real aha moment for Java devs.
It really is. It pushes us to challenge those old ways of doing things and really embrace new approaches.
And on that note, here's something for our listeners to think about. If you could completely redesign error handling in your favorite programming language, what would your dream approach look like? Let us know. Until next time, happy coding, everyone.